Greenland's ice sheet is melting at an alarming rate, and scientists have just quantified exactly how much ice is being lost. Here are the unnerving details. Greenland's ice sheet has lost 4,700 gigatons of ice since 2002, enough to submerge the entire U.S. under half a meter of water, according to a Polar Portal study. Within the overall trend, there is actually a small increase in ice high on the central region of the ice sheet, but ice loss is most severe along the West Greenland coast. The study used satellite data from GRACE, Gravity Recovery and Climate Experiment, and GRACE follow-on satellites to outline the dramatic changes in the ice, describing how the loss was most extreme along the edge of the ice sheet, where ice is thinning, and concluding that the melt has directly contributed to 1.2 centimeters sea level rise. Climate scientist Andrew Shepard, cited by Space.com, explains that for every centimeter rise in global sea level, another 6 million people are exposed to coastal flooding around the planet. A separate 2019 study in the journal Nature projected that under current levels of global warming, Greenland will contribute about 7 to 13 centimeters to global sea level rise by the end of this century. Scientists published a new study in the journal Nature Communications in which they show that Greenland's ice sheet is melting at such a fast pace that it's heightening worldwide flood risks. The study, which was published on Monday, November 1st, also found that the Greenland ice sheet has lost more than 3.5 trillion tons of ice over the past decade, which increased global sea levels by 1 centimeter. This one ice sheet contains enough ice to raise global sea levels by 6 meters, or 20 feet, and it has been experiencing an increasing number of extreme melting events over the past 40 years. The new research is the first to use satellite data to detect Greenland ice sheet runoff. The satellite images showed significant annual variation in ice melt and showed that heat waves were increasingly a major cause of ice loss above and beyond global temperature increases. In 2012 alone, for example, when changes in atmospheric patterns caused unusually warm air to hover over the ice sheet for weeks, 527 billion tons of ice was lost. 2021 saw the hottest ocean temperatures ever recorded, adding to previous records in 2018 and 2019, according to an Advances in Atmospheric Sciences study cited by The Guardian. Greenhouse gases released by humans are responsible for the rises, with more than 90% of heat generated by global warming absorbed by the oceans. Temperatures taken at least 2,000 meters deep are increasing fastest in the Atlantic, Indian, and Northern Pacific Oceans, but are rising everywhere relative to a 1981 to 2010 baseline. In 2021 alone, oceans heated by around 14 zettajoules, equivalent to 440 billion toasters running, or 7 Hiroshima bombs detonating, every second for a year. As oceans warm in this way, they threaten sea life, make cyclones and hurricanes more powerful, and cause rains to fall harder. The process also directly causes sea level rises because as water warms, it expands. The study cited climate model simulations as evidence that the increase in human-made greenhouse gas emissions is responsible for the trend, and study co-author Michael Mann added that until we reach net zero emissions, that heating will continue, and will continue to break ocean heat content records. Hammering home the point, the study also notes that the extent of the heating last year was such that even an ongoing La Niña event, a regular feature of the climate that cools waters in the Pacific, was not enough to see it buck the warming trend. The Guardian completes the story of this ongoing disaster by pointing out that the effects of such dramatic warming are also responsible for a vicious chain reaction, whereby heated ocean water expands and eats away at the massive Greenland and Antarctic ice sheets, which are shedding around 1 trillion tons of ice per year, and that in turn fuels more sea level rise. The Thwaites Eastern Ice Shelf, which acts as a dam to slow the flow of ice off Antarctica into the ocean, has a series of fractures spanning almost the entire shelf that could break it up within 5 years. The shelf sits at the front of 1/3 of the massive Thwaites Glacier, forebodingly known as the Doomsday Glacier, for its capacity to release massive sea level rises should it melt. At the moment, though it is already thinning, the shelf's leading edge is pinned in place by an underwater ridge, which means its ice flow speed is 1/3 of that seen in the glacier's western side. However, a presentation at a meeting at the American Geophysical Union, cited by the BBC, explained that the shelf is likely to become uncoupled from the ridge very soon. And even if that doesn't occur, developing fractures in the ice shelf will almost certainly break it up, which will release large sections of the glacier behind it into the ocean. Glaciologist Aaron Pettit explained to Science magazine that the shelf is like a windshield with a series of slowly opening cracks. You're like, I should get a new windshield, and one day, bang! There are a million other cracks there, she said. Science magazine adds that the collapse of the entire Thwaites Glacier, which some researchers think is only centuries away, would raise the global sea level by 65 centimeters. And because Thwaites occupies a deep basin into which neighboring glaciers would flow, this could eventually lead to the loss of the entire West Antarctic ice sheet, causing 3.3 meters of global sea level rise. Antarctic ice sheet melting could increase sea levels by over 5 meters by the year 3000 if current warming trends continue, according to a Journal of Glaciology study. The ice sheet's sea level contribution without reductions in emissions of greenhouse gases has already been assessed as rising between 7.8 and 30 centimeters by 2100, and now further simulations of mass ice loss show that by the year 3000, a continuation of current climate conditions would produce between 1.5 to 5.4 meters of increase. Such rises would make large areas of densely populated coastal land uninhabitable, while reducing emissions could allow for a rise of only 0.13 to 0.32 meters. The main mechanism behind the worst-case scenario rise is the potential collapse of the West Antarctic ice sheet, according to a study press release on Eureka Alert. The sheet is grounded on a bed that is mostly well below sea level, meaning ocean currents can deliver warm water to the area where the ice attaches to the bed. NASA's website explains this is the first step in a potential chain reaction where ocean heat eats away at the ice, the grounding line retreats inland, and ice shelves lose mass. When ice shelves lose mass, they can no longer hold back inland glaciers, so those glaciers can accelerate toward the ocean and thin as a result of that acceleration. This process then causes more acceleration and more thinning, and as more ice flows to the sea every year, sea levels rise. The U.S. National Oceanic and Atmospheric Administration says sea levels have already risen between 21 to 24 centimeters since 1880, and the rate has more than doubled from 1.4 millimeters per year throughout most of the 20th century to 3.6 millimeters per year from 2006 to 2015. Live Science reports that recent scientific studies have found a number of fascinating phenomena hidden under the 3-kilometer deep ice sheet that covers Greenland. One of these hidden phenomena is a huge canyon that is almost as big as the Grand Canyon. Stretching for 740 kilometers, this hidden canyon is up to 10 kilometers wide and up to 800 meters deep in places. Another study found a massive plan in the middle of Greenland that lies below sea level. This strange depression is probably caused by the weight of the ice sheet and is surrounded by a ring of hidden mountain ranges. Scientists were also thrilled to find evidence of a huge ancient lake bed that is now filled with a treasure trove of sample-containing sediment that scientists would love to access one day. Researchers also found evidence of at least 60 small lakes deep below the ice. These are filled with crystal-clear water that melted off the ice above. Scientists also found data pointing to at least 2 large meteor craters under the ice, and when an old ice core sample was studied more closely, scientists found fossils of plants that lived 1 million years ago. The acceleration of Antarctic ice loss in recent decades may already mark the beginning of a self-sustaining and irreversible period of ice sheet retreat, according to a study measuring historical ice sheet debris, which has identified patterns behind 8 episodes of ice sheet destabilization across recent millennia that could also apply now. The Nature Communications Journal study found that in the 8 previous episodes, mass Antarctic ice sheet destabilization switched on within only a decade or two, with bursts of iceberg calving causing the sheet itself to destabilize within only a few years each time, before continuing for many centuries, according to a press release published on Eureka Alert. The study also found that sea levels responded to these tipping points accordingly, also rising for several centuries and up to a millennium in some cases. One study co-author, Zoe Thomas, summarized why we should worry. If it just takes 1 decade to tip a system like this, that's actually quite scary, because if the Antarctic ice sheet behaves in the future like it did in the past, we must be experiencing the tipping right now.
For more news animations and explainers, hit the subscribe and bell button to join the TomoNews family. Thanks for watching.